Hello everyone, welcome back to Kota's Management. So this is episode 3 of our Agentic AI engineering playlist. So in episode 1, we discussed like what is Agentic AI. We understood the difference between the traditional generative AI and Agentic AI. Then in episode 2, we discussed like how AI agents actually work, and we learned like about the agentic loop, like how there is one goal, like user's goal, then the agent actually observe that, then reason it and plan accordingly and do the needfuls like the acts, and after that again observe the result and continue or finish like that. So today we are going to discuss one step further. Our topic is agentic AI, agent architecture patterns. So there is no single way to build an AI agent, right? So like depending on the problem, we can use different architectures. So today we will understand basically the React, plan and execute, then router, sequential workflow, parallel workflow, human in the loop, supervisor. Next, like comparing between like single agent workflow and multiple agent architecture. And we will learn like how to choose the right pattern, right? So next, our part one actually we discuss with a very important questions like why do we need agent architecture patterns? So we actually just let's imagine that we have an AI agent. Okay. So we give it access to 20 different tools. For example, like there are several operations like searching operations, database, emails, payment, customer API, order API, weather API, calculator, ticketing systems, file systems, several tools we have, right? So now we simply tell the LLM like do whatever is necessary. So this may work for a simple small demo, but in a real enterprise system, this can become very difficult. Okay. Like the agent may select the wrong tool, call too many tools, repeat the same action, spend too much money, take too much time. It can perform an action that should require approval, become difficult to debug. Okay. So we need some good architecture. So think about software engineering. Like we don't normally build a large application without architecture, right? So the same idea applies to AI agents as well. So architecture gives us the proper path, proper structure. So like there are basically different agent patterns. Like let's look what are the patterns. So we have the React, then planning, reflection, router, workflows, like sequential workflow, parallel workflow, then human in the loop, like human approval is required. After that, multi-agent is there. Okay. So one by one, we will cover the things. So first of all, we will start with the pattern one, which is the React pattern. So let's start with one of the most common patterns, React. So React actually represents a reasoning and action style of agent execution. So the basic idea is there will be some goal. The agent will start to reason about it, then do the needful act, observe the result, reason again, act again, then finish. So let's understand this with an example. Suppose the user says, like, find the current weather in Kolkata and tell me whether like I should carry an umbrella. Like what I should carry, like that. So the agent first thinks, like I need weather information, right? So then it calls a weather tool. So the tool returns like suppose temperature is 27 degrees Celsius. What is the percentage of rain? Like 80%. Okay, now the agent observes the result. So observation. Whatever weather result will come up, it will observe. So it thinks like there is a high chance of rain. So it gives the user like, yes, you should carry an umbrella. So this is actually react, like reasoning and then act. Then like there are several advantages of it. Like simple mental model. After that works well with tools, then adapts after every observation, useful for dynamic tasks. But there are very many limitations as well, like may require many model calls, can increase cost and latency. Like if there are multiple tool calling, external tool calling, then the cost will be increased, right? Then can loop without good stopping rules. Then less predictable than a fixed workflow. So there, like React with multiple steps actually there. So now let's make the task more complex. Like here, I have just given one simple task. But if I will give some complicated task, like find a good laptop under 80,000 and compare three options. So what will be the flow now? Just think the steps. So there is a goal to buy the laptop, right? So according to that, the model will reason about it. Then search the products. Then after searching, it will observe the results. Then filter by price, right? Then search particular specifications like what is the what GB of RAM it's require and multi-core or what is the chip what will be required. Okay, what memory will be required? According to that, what is the processor specifications? According to that, it will give you some options. Okay, so after that, it will observe the result, then compare, and it will give you the final answer. So notice something important. What is it? Like the agent does not necessarily know the complete path before starting. Okay, so the next steps depends on the previous result. You got it? For example, if the search returns no laptop under 80,000, the agent may need another approach. So that is why React is useful. So when should we use that one? So React is useful when the task is dynamic in nature. The agent needs tools. The next step depends on the previous result. So we don't know the exact sequence beforehand. For example, like research, troubleshooting, customer support, data investigation, or like some search-based tasks are there. But React also has disadvantages that I have discussed. Okay. So, like whenever these more calls are required, then more latency, more cost, more opportunities for errors are there. So we should not use React for every problem. So after that, we have the second pattern as plan and execute pattern. So here, like instead of deciding one step at a time, the agent first creates the plan. The basic flow is there is user goal, then particular planner is there. It will create the plan, then executor are there, then execute the step one, step two, step three, and it will get the final result. So let's take an example that prepare a report comparing sales for three regions. So the agent can first create a plan. So plan is like get sales for region A, get sales for region B, get sales for region C, compare the numbers, calculate the growth, and prepare the report. Then the executor follows this plan, right? So now you will going to learn like why plan and execute pattern is required. So imagine a task with 10 or 15 steps, right? So like if the agent decides everything like one step at a time, so it can become difficult to understand the overall direction, right? So with plan and execute, we have a high level plan actually. Like suppose there is some goal and the agent will start to do some planning and it will do the research, then data collection, analysis. Okay. and after that comparison, and it will generate the reports. Okay, so this makes the workflow easier to understand actually. Okay, I think yeah, it's clear to you, but there are some limitations like what if the plan is wrong? So suppose the agent creates the plan, it will get some sales data, calculate the growth, and create the report. The example actually what I was given to you. So the agent need to replan, like when suppose at the step one, like when it was trying to fetch the sales data, suppose the database does not contain the required data. So now the original plan cannot continue, right? So the agent needs to replan. So whatever original plan, after execution of that, we got some issue, like we got some problem. So then we need to replan, then new plan. After that, need to do the execute again, and it will be continued. So that is actually called as the replanning. So plan and execute does not mean that the first plan must always be followed. So a good architecture can adapt when the situation changes. Okay. Now we will also will know about like we have discussed the react pattern and the plan and execute pattern. So what are the difference? Like we will compare between these two. Okay. So here what I have told you, that there was some reason, then act, then observe, then reason again if required, and act again, and then finish. But for plan and execute, there is a goal, then planner, then create the plan, execute the plan, and replan if it is required. So the simple difference is React basically decides step by step, right? But plan and execute creates a larger plan first. Here, one by one step is there. You can see here after the goal only planner is there. Okay, so it will make a great plan first. It will create the plan, then execute the plan, and if it is required, then it will do the replan. So for dynamic task, the React is useful. Okay, as after getting the goal, it will reason, then according to that, it will add. But see, like if it is a large steps are there, then if initially the plan will be scheduled, and then suppose that plan failed, then again need to plan. It will be time consuming, right? So for dynamic task, always React pattern is useful. But for for larger structured task, whenever it is properly structured, we know that particular plan can be, if we will execute that particular plan and we will get some success path or happy paths, then for that plan and execute will be useful. Otherwise, we need to do again replanning and reacting the things. Okay. So more resources will be consumed, more times will be consumed, right? So next part is we will know the third pattern, which is the reflection pattern. So the idea is very simple. Like instead of generating an answer and immediately returning it, the system basically reviews the answer. Okay, so it will generate something, then it will review. It will check it is good enough or not. If it is, then finish. Okay. Otherwise, like if it will be yes, so actually it will be like that only. If it is good enough, then finish. And if it is no, then retry through improving and reviewing again. Okay. So that's the proper structure. So suppose we ask an AI, like who write a Java implementation of a payment service. So the agent generates the code, but before returning it, another step basically reviews the code. Okay. So the reviewer checks basically the is the code valid or not? Are exceptions all handled or not? Is the design reasonable? Are there actually any security issues are there or not? Like are the missing validations or not? So if problems are found, the system improves the code. Okay, now why that reflection is required for any content? So reflection is not only for code. Suppose we ask write a technical article about Kafka. So the system can first create the draft, then it will basically review it, right? So like it will check like is the explanation correct, are important concepts missing, is the structure is properly there, like is the structure clear or not, are the examples also useful or not, real life examples are mentioned or not. It will basically check those parts. Then if it is required, then it will improve, and then again review it, and if it is okay, then it will be finished. Okay, so in this way, it basically try to improve the uh, quality. But there are some limitations as well. Like we should not assume that reflection guarantees like correctness. And AI reviewing its own answer can still make mistakes, right? So also reflection requires additional model calls. So that's why it generate, then review, and again improve. So can be more expensive than generate process. So we will use the reflection when the quality improvement is worth the additional cost and latency. Like otherwise, every time it will call again and again, recalling is required, reprocessing will be required, huge cost, huge resources will be required. So always use the reflection when the quality improvement worth the additional cost and latency. So next we will know about the fourth pattern, router pattern. So a router is like a traffic controller actually. So it receives a request and decides like where the request should go. So you can think that pattern with a API gateway we learned in system design playlist, right? So if you have not watched, you can go to the system design playlist and watch the uh, functionality of the API gateway, okay, and load balancers as well. So here we can say the router is just like a traffic controller. So it receives a request and decides like where the request should go. So imagine a company's AI system. Okay, so it supports like sales agent, customer support agent, uh, and technical agent. So the user says like my payment failed. So the router identifies the request as a payment support issue. So it will like whenever user request with that through the router, it will go a particular payment support agent. Okay. So suppose another user says, show me quarter two sales. So the router sends it to the sales agent. Suppose another question is like another user suppose asks, like how do I configure the API? So the router sends it to the technical agent. Okay. So in that way, actually it is. So uh, the architecture will be looks like that. Okay. So this has an important advantage. Like every specialist does not need access to every tool. Like for example, the sales agent may access sales database, analytics tools, reporting tools. Okay. The technical agent may access like the documentation, code search, API tools. Okay. And this can make the system easier to control. Okay. So we will know about the uh, router versus supervisor. So like there is another thing, supervisor is there that I'm going to explain also. Like a router basically answers like which path should handle this request, right? Through that, like whatever questions the user will ask, according to that, it will segregate that. Like which path should handle this request. Just suppose one will ask the sales related problem. So then it will go to the sales agent. But supervisor actually asks like which agent should work on this larger task and how should I coordinate them. Suppose there are several agents like research agent, data agent, analytics agent, writer agent. So the supervisor basically can coordinate multiple agents. So the router means it will choose the path. Okay. And supervisor is like to coordinate the workers. You can think the supervisor as like load balancer. Like load balancer basically checks like which server is healthy, and according to that it will serve the or it will give the traffic to that particular server, right? In that way, the supervisor also basically coordinate the workers, but router you can think as the API gateway that basically choose the path. Now next fifth flow, like fifth pattern is like sequential workflow. So a sequential workflow is simply like step by steps, all will be covered. Like step one, then step two, then step three, step four. So for an example, suppose there is one invoice processing system. So some invoice will be received as an input, then it will extract the information, then it will validate the invoice, then check the vendor like processing the like transformation and processing it. Then it will do some like business logics as well. Like it will check the vendors and all the business logics also. Then it will store the invoice. Then after that it will send the notification and we will get the output. So here the sequence is already known. We don't necessarily need an autonomous agent. We can simply implement the workflow. So like, should we use AI in every workflow? So this is a very important engineering principle. Like, suppose if a process is deterministic, we should generally keep it deterministic. Okay. Like, suppose we need to validate some order, then we need to save the order and then we will send the email. So there is no reason to ask an LLM like, what should I do next? So the developer already knows what should happen next according to the business orders. Like we need to validate order first, then we need to save the order or persist the order. Then we need to send the email. Okay. So a traditional workflow can be like faster, cheaper, easier to test, more predictable. But AI agents are useful when decisions need flexibility, dynamic. So next there is parallel workflow. So now let's imagine that we need to perform three independent tasks. You know about the completable future? If you know, it's okay. So like in the asynchronous, actually, as I have worked in backend engineering, I used to work actually. So I try to correlate with the AI engineering things as well. Whatever our system is, whatever system we are using, according to that, actually, I'm trying to uh, make a bridge to fill the gap. Okay. So suppose now let's imagine we need to perform three independent tasks. Okay. So for example, like source A, like search the source A, search the source B, and search the source C. So there is no dependency between them, all are independent. So instead of doing sequential like A, then B, then C, like in the synchronous program, what I do in the step by step we need to do, right? Then the time required more. But in asynchronous process, we do the task parallelly through the completable features. We can do that, or through the executor service, we can do that. So we can execute them in parallel. Suppose search A, search B, and search C, as these three tasks are independent on each other. So we can do the task parallelly. So it will reduce the total waiting time. Okay. So do not parallelize dependent tasks. So if task B depends task A's result, task B must wait. Okay. So when can we use the parallel execution? So suppose we want to prepare a market report. We need market data, competitor data, customer data, right? So if these three sources are independent, we can query them at the same time. Then we can do like we can get the market data, then we can get the competitor data and customer data. And competitor data, then like after getting all those three, we can combine and we can do the analysis. So for the completable features also, there is one lecture I have already done in this code type management. You can go there, you can understand the completable future and all. So there also you can see like how multiple tasks can be done parallelly, how combinations work. Okay, that actually I have discussed there as well. Okay, so but there is an important rule. Like suppose what I've told, like if the task B depends on task A, then we cannot execute them independently. We need to follow the steps by step there. Now human in the loop. So like it is the most important enterprise patterns, human in the loop. So like an AI agent should not always have complete freedom. Consider the request, suppose transfer 10 lakh to some account. So do we want the agent to immediately execute the transaction? Probably not. So there we need an agent, then prepare the action. Then there basically some approval will be required. So if yes, if it is yes, so then it will be executed. And if it is no, then basically there will be some human review, right? And then approve or reject and then continue. So this gives us the control actually. So now where human approval is useful, like human approval can be useful for financial transactions, production deployments, account deletions, large refunds, sensitive data access, legal decisions, high impact business decisions. So the agent can do most of the preparation, but the human makes the final decision. So this gives us automation with control, and that is the best part. Okay. Next, we have already discussed about the supervisor, when we were comparing with the router pattern. But again, I am just uh, telling you. So, like, suppose we have a complex business problem. So the user says like analyze our product performance and prepare the recommendations. So this may require several skills. We might need research, data analysis, business analysis, report writing. So instead of one agent doing everything, we can create specialist agents like for research, research agent, for coding, coding agent, data agent. After that, supervisor will check those agents' results. Then the combinations will be done and we will get the final answer. So, like the whenever suppose it will be asked, like suppose one example, like analyze like why our product sales decreased and prepare recommendations. So the supervisor might do like ask the data agent, like analyze our sales data. So the data agent returns like sales decreased by suppose 16 or 18% like that. Then it will ask the research agent like check the market trends. The research agent returns like suppose two competitors launched cheaper products. So it will ask then the business agent. So it will ask like analyze the possible business reasons. So then the supervisor combines everything and finally we will get the final analysis and recommendations. So here I have told like we have used the specialist agents, but why it is necessary? So because specialization can help for example like research agent is responsible for search, research, external informations. Suppose there is data agent. So data agent basically responsible for like any SQL related task, data analysis part, statistics. There is coding agent who will do the codes. And maybe there will be some writer agent as well who will be responsible for like writing reports, summaries, documentation. So each agent has a focused responsibility, no mixture of anything. So parallelly also we can do those things. Now we will know about single agent versus multiple agents. So here as a architecture, it is for single agent, one main agent will be there. For multi-agent, multiple specialized agents are there. Complexity for single agent is lower, multi-agent is higher. Tool management for single agent it is centralized, multi-agent can be distributed. Specializations like single agent is for the general purpose, but multi-agent like it's their specialized roles are there. then debugging is easier for single agent, but for multi-agent, more difficult. Cost is like usually lower for single agent, and for multi-agent, it's can be higher. Best fit like moderate complexity. When then we can use the single agent, and if the complexity is higher, so then we have to use the multiple agents. But we also need to know like why multi-agent is not always better. So this is another important point. Like people sometimes thinks like multi-agent is more advanced, so it must be better. So not necessarily. Like multi-agent systems introduce additional complexity. Suppose there are agent 1, agent 2, agent 3, agent 4, and step by steps all are working. So now we have more model calls, more latency, more communications, more failure points, more debugging, more cost. So use multiple agents when specialization provides real value. Other than that, it will not require. Okay. Now, how to choose the right pattern? So now we come to the most important section, which is like how do we decide which architecture to use? So start with the business problem, like whatever business problem is there, according to that you need to think. So first, just you need to think about like, is the process predictable? If yes, so you know the paths, right? So the sequential workflow will be better. Now you need to check like, are there independent tasks? So like if multiple tasks are independent to each other, then you can use the parallel workflow. Now suppose, does the agent need to dynamically select tools? So for that you need to use React. Whenever any dynamic behavior you need to think about, then you need to use the React architecture. Then you need to ask like, is the task large and multi-step? So then you have to do like plan and execute. Then suppose like, does the result need an additional quality check? Then reflection is required. As in the reflection, I have told you, see, like if here, if yes, then fine. But if it is no, then again improve. So quality check is going on. So then you need to use the reflection. Okay. So next, suppose are there different categories of requests? So if that, then you have to use the router. Then you have to think like, does the task require multiple specialists? So then supervisor or multi-agent you can use. Suppose is there like the action is sensitive or irreversible? Then you have to use the human in the loop. Okay. So one problem, different architectures are there. Okay. So let's take one business problem. Like suppose we are building an online customer support system. So the user says like, my order has not arrived. So you could solve this using a sequential workflow, like receive the request, identify the customer, then check the order, then check the shipment, and then respond. We can solve it using the React as well. So like there will be a goal, like customer support system. So there is goal, then it will reason, then tool, observe. Again, it will reacting, like again reasoning, tooling, and observing. There, suppose router, through the router pattern also you can solve. Like if there are multiple agents, so there are like order agent, payment agent, technical agent. So if the user says like, where is my order, the router selects order agent. If the user says, why did my payment fail, it will go to the payment agent. If some technical glitch, it will go to the technical agent. Now same problem using the supervisor as well. So from the customer, the request will be received to the supervisor, and from the supervisor, it will ask accordingly like customer agent or order agent, policy agent or resolution agent accordingly. So the supervisor basically coordinates multiple specialists. So again, I am going to just comparing between this React and uh, plan to execute that we have already covered. This react and plan and execute. So react says like the agent says that what should I do next? Then acts, then asks again like what should I do next? As it is step by step, right? So it will reason, then act, then observe, and reason again. But for plan and execute, the agent says like what are all the major steps required. So it creates the plan, then executes it. So plan, then step one, step two, step three, like that. So remember, like React actually dynamic step by step decision making. But plan and execute basically plan first and execute after that. And router and supervisor have already discussed. So basically, router actually we use when like one request comes in. Like router basically chooses one path. The request will comes into router and router actually sends it to the particular specialists. Okay. Like if it is sales related, sale to the sales agent. If it is support related, then support agent. If technical related, then technical agent. But supervisor, like when a complex goal comes in, okay. So at that point of time, supervisor can delegate different pieces to multiple agent. Suppose a complicated query it came. So it basically segregate the particular task and do the communications with those specific agents. So router basically chooses, but supervisor basically coordinates. That's the main difference. Many people just got confused between the router pattern and the supervisor pattern. But router actually choose the paths and it will send the request to particular specialist agent. But for supervisor, it basically coordinate with the particular agents. That's the main difference. Now, there are some production guardrails. So, like that's the architecture decision process. Suppose start understand the business problem. Is it predictable? So, just a second. So here it will be just yes. If it is no, and here also if yes. Okay. So just understand the business problem. Like, is it predictable? If yes, then workflow. If no, then agentic pattern. So now need flexible tool use. If yes, then React. No, then other pattern. Need explicit planning. Then plan and execute. Need quality review, then reflection. Need specialist, then router or supervisor. Need approval, then human in the loop. So that is the mind map. You always need to plan accordingly. So some production guardrails are like a demo agent might work with uh, like LLM and tools, but a production agent needs more. Like there should be some guardrails like validations, authorizations, some limitations. Like who is using the system? What is the agent allowed to do? Are the tool arguments are valid or not? Like how many times can the agent call a tool? Like how long should we wait? So maximum iteration limits, audit logs, tracing and observability, human approval for sensitive actions, what need to logs. So these are the essential for enterprise systems. So these are the guardrails. So there is one guardrail layer should be there. Then according to that, it will call the tools and like external APIs or database, something like that. Now learn about the observability. So agent systems can be difficult to debug. So imagine one user request creates like uh, request and then it will go to some LLM call. Like then it will search something again LLM call. Then it will go to the database, then again tool call or LLM call. Then suppose it will do some API, then LLM call some, it will give you the final answer. So if something goes wrong, we need to know where. So we should track the request ID, agent name or workflow name, model call information, selected tool, tool execution time, success or failure status, iteration count, errors and retries, final outcome. So this is called the observability. So this is also we follow in a normal traditional workflow as well through some micrometers or some open telemetry, right? So that is very much important. Now cost and latency. So agent architecture also affects cost. Suppose a simple task requires one LLM call, but a complex agent might require multiple LLM calls. So when one LLM call for simple task, then it is very cheap. But when there is multiple LLM call or multiple tool call, now we have many calls. So that means more tokens will be required, more API calls, more latency, higher cost. So that is why architecture design matters. So always do not use a complex agent architecture just because it looks advanced. So start with simple, like simple workflow. If that solves the problem, stop there. If you need dynamic decisions, then add agent. If you need some planning, then you add planning. If you need some quality checking, you need to add what? Reflection pattern. If you need multiple specialists, then add a router or multi-agent. So build complexity only when that is required, when there is a particular reason. So start with the small, simple workflow. Add one agent, add tools, add some state, add some guardrails, then add observability, then measure, then add complexity only when it is needed. So this is much better than starting with like 10 agents, 50 tools, complex memory, complex planning. So without knowing whether we actually need them, we don't add anything, any tools or any agents blindly. Okay. So suppose there is some travel planning, like plan a 3-day trip with places to visit, estimated budget and a daily schedule. So if we will follow the React pattern, so it will go search the attractions, observe, search hotels, observe, then calculate budget and generate a plan. If plan and execute, then first do the plannings, like find attractions, find hotels, estimate the transport, calculate the budget, build itinerary, and then review the plan. If it is supervisor, then for the supervisor, there will be some specialist agents like research agent or hotel agent, budget agent, itinerary agent. Then whatever requirement is that, like plan a 3-day trip with a places to visit, estimated budget and daily schedule. So research agent will actually search the available hotels. Then hotel agent, it will book the hotels. To the budget agent, it will estimate the budget, and there is itinerary agent who will do the relevant tasks. Now we will know about like common architecture mistakes. So like using an AI agent when a normal workflow is enough. Mistake two, like giving the agent like unlimited tools. Then like allowing tools without proper authorizations, no maximum iteration limit, no timeout or retry strategy. Like if we will not do these retry strategies or failover mechanisms, then if something will fail, the whole process will be stopped there only. Like suppose for critical task, then no human approval is there. So then suppose 10 lakh transactions happened, then where the target account, it can be misleaded. The wrong account can be selected and your 10 lakh rupees can be gone. So using multiple agents without clear responsibilities, that is one big mistake. Adding reflection to every task, that is one big mistake. Like everywhere we don't focus on quality, right? Wherever the quality matters, we will add the reflection pattern. Otherwise, it is not required. Then somewhere we actually ignores cost and latency. But for production environment, we always need to focus on the cost and latency. and design the architecture before clearly defining the business goal. We need to understand the business goal, then we need to design the architecture and then need to implement the things. So recommended development strategies like start with a small simple workflow, single agent, then add tools, then add state, then add guardrails, then add observability, then measure the quality, cost, latency, only then add complexity, router, multi-agent, and supervisor. Now, important interview questions can be like whatever I have discussed, and they are those things only. You can cover like whatever patterns I have discussed, like react, plan and execute, then reflection, router, supervisor. When should you use a workflow instead of an agent? Why can multi-agent system cost more? Then why are guardrails are important? Then what is human in the loop? How do you choose an agent pattern? So that is the thing. Okay. So like what actually we have learned today? So we have discussed all the patterns, react, plan and execute, reflection, router, sequential workflow, parallel workflow, human in the loops, supervisor, multiple agents. So suppose 8, 9 flow we have covered. So that is the final shift for React plan and so like for every flow, what is the thing? So that's it for today's episode. So let's quickly remember the main idea, like not every problem needs an AI agent, and like not every AI agent needs a multi-agent architecture. So start with a simple solution. If your workflow is enough, then use a workflow. If you need dynamic decision, then consider an agent. If you need planning, use the plan and execution. If you need quality checking, then add the reflection. If you have multiple tasks, then you need to use router pattern. If you need multiple specialists, consider a supervisor or multi-agent architecture. And for sensitive actions, always consider human in the loop. So in the next episode, we will focus on one of the most important building blocks behind agents, like tools and function calling in agentic AI. So we will understand what exactly is an AI tool, how does an LLM decide to call a tool, what is a tool scheme, how are tool arguments generated, how does function calling work, how do we connect tools with APIs, how do we connect tools with databases, how do we handle the tool errors, how do we secure tools, how can an agent call multiple tools. All those things actually we will cover. So this will be a very um, scenario based practical type episode, because we will start moving from architecture concepts towards actual implementations. So thank you for watching Code Type Management. If you are following this agentic AI engineering series, continue with this playlist, because the each episode builds on the previous one. So see you in the episode 4. Till then, stay tuned and do like, share and subscribe much more, so that I will get some motivation to make such contents like that. Okay. So thanks everyone. Bye.